Hello, welcome back to my bench. If this is your first time here, hello. My name's Dave. I fix electronics mostly for the broadcast industry, radio in specific. But today we're not going to do that. Today we're going to work on a kit. This isn't actually a kit. It's a kit that I designed, sort of. It's really simple. It's basically it's an updated version of my op-amp tester, which is this little guy here. It's this works very well. It's basically you stick an op-amp in it. This is a single. These are duals, and these are quads. If they're standard footprint, they fit in there. And if the single is good, this light over here flashes. If the duals are good, then these two lights flash. And if the quads are good, then these four lights flash at about a rate of 10 hertz. It does have inputs and outputs to put an external input into it and raise and lower the frequency to see if your op-amp's good at higher frequencies. And it also has an output here to go to a scope so that you can take your output to a scope and see what it looks like. And this switch is for internal and external input over here. It runs on a 9 volts. It has a little 9 volt in, plus or minus 15 out. There's a video of this. I'll leave a link up in the top up there someplace. Where is it? Yeah, up there. Just so you can go look at that. This thing works great, and I love it. I use it all the time. I use it enough that I've worn out the IC sockets. They weren't good to begin with, but they were not. They're just not a good solution for that. So I sat down and I designed one with a 40-pin socket, like this. It should make things easier. The way I've got it set up is the first 8 here, 1, 2, 3, and 4 are for singles. You skip 1, and then the next 4 are for duals, and then you skip a couple in the middle here, and from the bottom up, the last 14 or 7 of them are for quads. So with that in mind, I designed this little board. This thing took me quite a while to figure out. If you look at the schematic, I'll bring it over here. If you look at the schematic, you'll notice that I didn't really put in the ICs that I wanted to test because I'm using KiCad or KiCad or however you pronounce it. And when I tried to put in 3 ICs, the single, the dual, and the quad, and then somehow assign those to a footprint of the 40-pin ZIF socket, I could not figure out how to do that at all. It took me a while to find out what I needed to do, and that was to put this, dual 40-pin counterclockwise connector, just a standard connector out of the stuff that you've got to select from. And if we look at it, you'll see here that it is a connector 02 by 20 counterclockwise, and it is set up as a socket dip socket 40 wide, whatever. Anyway, for the footprint. If we go look at that footprint, there it is, right there. It's listed under sockets. There's several different kinds, but this was the size that I happen to have. I stole it off of a old IC tester that I had, and it it worked. So what you end up with is, if we go look at the board, where's the board? Here is the board, I think, if I can get it over there. Yeah, there's the board with everything laid out on it. Now, I did, in the old version, I put on the wrong connector size for these guys here, for the power, which is up here, for the external or the input, which is here, and for the scope outputs, which is here. I had little tiny itty bitty ones I've never seen before, because I didn't look at it right. I mean, if you look, if we look at this thing, you'll see what I mean. These are really small. They worked okay for the wires coming out of it. It's, since I mounted this thing as the board right on top of a box, they worked okay, but they're pretty fiddly and fragile. So I changed those over to the newer sized pins, which are going to be these guys here. Little right angle, 90-degree right angle, just plain old headers that I'll be able to either put plugs on or wire directly to, whichever, but it should be better. And then the rest of it is all surface mount stuff, except for the LEDs, which go along here. So we're going to put this thing together real quick, and we're going to start doing that by putting on the LEDs, or the resistors. It only has two different values of resistors. It's got 1Ks and 10Ks. And if we look at the schematic, which is here, you'll see that all your resistors, these are all 1K here. I screwed up. These are 8, 9, 11, 12, 10, 14, and 13. Those are all 10Ks. And then the 15, 17, these guys over here on the outputs are 15, 17, 21, 20, whatever. I wasn't real careful about numbering them, but those are all 1Ks going out for the LEDs. So that's all that's on this thing. It's pretty darn simple. So we may as well start putting this thing together. The board, by the way, is from JLC PCB. They did a good job this time. I set it up so that the bottom of it is all ground plane, and the front of it is where everything goes, basically, since it's service mount. Most of it's service mount. And I marked off little areas here where it just got rid of the shadow mask. It got rid of that so that it marks where your ICs go. And it says down on there single, dual, and quad, but you can't read it. I should have made those different, but I didn't. But anyway, you'll see where it goes when you get it done. So let's see. I think these are 1Ks, 102s. Yeah. So there's some 102s. In this case, I'm going to need, going out to all of the LEDs, those are 102s or 1Ks. And then the inputs, 1, 2, 4, 5, 6, 3, and 8 are all 1Ks. So I'm going to need, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 8, 9, 10, 11, 12, 13, 14, 15 of them. So I got what here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Well, there's 10. We can get started with that. Dump them in there. Get a set of tweezers. And I'll probably zoom through this just because it's not all that entertaining. I understand. Let's do these guys first. Get one end. Of each of these. I made a little bit of a change in my the way I've got my camera set up here, so that I can look at you while I'm reading a screen. I got a little 8-inch monitor right underneath the camera so that when I'm reading stuff off of that screen for schematics and stuff like that, I'm not staring up at the monitor. Tell me if you like it better. I think it works. I did a little experiment with it, and I thought it looked pretty good. At least it looked better than it did before. And R8. All right. So, yeah, this was such a small thing that I didn't bother to get a stencil for this, and I'm not going to bother to try to float these guys, on here. This is just really pretty simple. Alright, I'm just going to shut up and do this and zoom through it, I suppose. Okay, let's take a look at that. See what it looks like under the glass here. I don't know if you can see that or not. Not the prettiest things in the world, but they all appear to be soldered down. Alright, so much for the 1Ks. Put them back. That way you know where they're at the next time you need them. Okay. And these are 10Ks, which would be, what, 103s? Yeah, not those, these. And these are 1002. Okay, interesting numbering scheme. Okay, so we're going to need 1, 2, 3, 4, 5, 6, 7 of these. Let's see, I need 13. Yeah, so there's 1, 2, 3, 4, 5, 6. Did I goof up someplace along the line here? Let's, yeah, because I need R8. Oh. Yeah. I did. Of course I did. The single op amp is supposed to be 7, so it's supposed to be a 10. So there's a 1, 2, 3, 4, 5, 6, 7. All right, back at it. Okay, I think I got them all on there, but they are ugly. I'm gonna see if I can get these things to at least settle down a little bit better. Bring up the heat here. It's about 408. Yeah, there's too much solder in each one of these, but I'm not using the right kind of solder. I mean, I'm just hand soldering these into place. I don't have any chip solder that's any good, because every time I buy some, I end up not using it for so long that it goes bad. I do keep it in a little refrigerator. That looks a lot better. Okay, so next thing is to put in the LEDs. All right, so I got out a bunch of LEDs here. I wanted them all to look kind of the same. So I got 3 and 4. These are a little bit longer and brighter. They're, I just measured them at 2 volts and see what they look like. And they're pretty good and bright. So I'm going to put these first 3 that I've got for the single and the duals. And put them right up here. I would have gone with all 7 of these, but I didn't have 7 of those. So all of these, the long one is the plus. Okay. All right, and then these guys, these are all the same, so I'll put them on the 4 for the quad output. They don't fit all the way down to the board like the other ones did. Oh, there's a little. Yeah, they got little legs there, or arms on the legs there that keep them from going all the way down the board. Won't make any difference. Okay. There's the last one. All right, so long, 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 long. Okay, good. Last one there. So, chop these off. Not cutting into the little mound of solder there, just right on top of it, or trying not to. That one was a little close. They all look good. Well, about as good as they're going to get, I guess. Okay, now we got the big old 40 pin here. Stick him on. Huh. Wow, all the legs were straight enough and went right in. I am amazed. All right. So, here we go. Okay, let's check it. Yep, they all look good. No shorts. Okay. So those are on, and that's on. So now, let's put... Probably should have done this first before I put on the big one. Yeah, of course I should have. Oh well. We'll do the three-handed. Yeah, sure we will. I used to be better at this three-fingered thing here. I'm not as good as I used to be at it. There's one, but let's make sure it's reasonably straight. So you heat this up, make sure it's straight. Do not hold on to the one that you are soldering to, because it's going to be really hot. All right. These guys, you got to be kind of quick, because you will melt the plastic on the other side. Why are you not working? Did not melt the plastic. Yay. But did everything look okay? Yeah, it does. Okay. Now for the input. That's for the output for the scope output. This is going to be the input. 3 wires for power. Because there's plus and minus 15 volts. Alright, this is going to hurt because there's only 3 of them, and by necessity my finger has to be on top of one of them. Yes. And the last one, this is for auxiliary input. And this is going to be rather warm also. Yes? Okay. All right. So, all put together. So let's clean it off a little bit. Yeah. Where's my alcohol? I got more alcohol coming out of isopropyl alcohol. Fortunately, I ordered some, and this will do. I have not put this board together. You guys are seeing it the first time with me. I've just hoping I did everything right on the schematic and the board itself. That's good. Looks good. All right. So now we got to hook it up. See if it works. That means I'm going to have a bunches of little clip leads here. So I'm going to have, I'll use my bench power supply for the plus and minus 15 volts at this point. Okay, so black's going to be ground. This one's going to be plus 15. And then I'll get another little one. Be minus 15. Going to have to remember which one's which. Wow, that is tight. All right, so this one is minus 15. So it is marked on the board, but I can't really see it. Minus 15 goes down to the bottom. Get that out of the way. The middle is ground. And the other side is plus 15. All right, now let's see if we got any shorts. Nope, 15 and 15, so that's working okay. They're going to need an input. Let's take this guy here. This is so big. I got 1,000 hertz, or 1 kilohertz in today's parlance. So let's, where is it? Function generator. Let's see. I want like 1 volt. No, it does not like doing that. 1 volt. 1,000 hertz. Did it actually register that? Yes. And I don't think it is a sine wave. Offset is 0. Okay, I was messing with the offset earlier. So offset is 0. That's going to go to the input up here, which I think is this direction. Okay. Get away. Thank you. All right, and I have a sacrificial lamb here. It's a TLO 74-ish, which will go with the point going that way, and in the last section. Well, if all goes well, these lights, oh no, I want 10 hertz. That's right. 10 hertz at 1 volt. Cross your fingers. Let's see what happens. Well, I got 1 shorted, 2 blinking, and this one not working. What happened? Now I got 2 shorted. Oh, what did I do? Why does it keep changing? Got 2 blinking, and 2 say they're shorted. Nah. 102, 102. Okay, 13. All right, so I got to check over this thing and see what I did wrong. I don't think I did anything wrong. Hang on, I'll be back. Okay, so I figured out what I did wrong. If we look at the board layout here, bring it up. All right, so here's the board layout. You look at pins right here at pin 16, which is the input, the positive input, and pin 18, which is the positive input on the 4-wire, or the the quad. If you go over here and you look at 23 and 25, they are supposed to be ground also. However, they're not on here. For some reason, I don't know why. And neither is 32, which is supposed to be ground. 32 is ground, but it's never going to be ground because of this weird little cutout here, the way this is made. So what it means is I'm going to have to go back through and figure out why it didn't work. What I did for right now, show you. I ran some jumper wires. That's 23, 25, 32, pin 3 also, which is on the single, and ran them over to ground with a little piece of tie wrap or wire wrap wire. So now get back on there. So now we give this a little electromotive force. And I know you can't see that very well. Let me give it a little more. Let me give it 2. There. Can you see them flashing? All 4 of them are flashing. That means that guy is good. Let me go find a dual and a single. All right, so I've got a TLO 71 op amp here, which is a single, and I've got NE 5532, which is a dual. So we'll put those. Well, first of all, we'll release this so we can put them in there. All right, and this is the 5532, I believe. Yeah. All right, so there's the 5532, and this is the TLO 71. So we'll put him up here. We'll put him in there, and we'll lock it down. And we'll turn it on, and hopefully all the lights will flash at about 10 hertz. The duals do, the single... Let's take that voltage down a little bit here. I don't know why this one's flashing. Oh, it's flashing. Oh no, it's this one. Is that the 5532, or is that the zero insertions force socket? Can't tell. I must have a bad solder joint or something here. That one's flashing. These guys are flashing. The single is flashing. Let's see if I got a bad solder joint. I don't think so, because that's going to be. We're going to have to take a close look at this, or I am anyway. Okay, I see why it didn't. Okay, I'm going to correct the thing. The reason these did not go to ground is because the fill here, it filled, but it didn't connect it to ground in any way, shape, or form. They are actually grounded in there. You probably can't see that, but they are grounded, or at least to this fill. I didn't look real careful at that, and that's why. So what is my problem here? Let's take these guys out for now. Okay, so that's a problem with the fill. All right. Let's see. Yeah, this other one didn't fill. It didn't go to ground either. So I'm going to have to make some corrections in the board itself, and when I order the next set. But I got this one over here. Not working, and I do not know why. Well, I'm going to try give it a touch up here and see. So it was this one over here, right? Yes. It seemed to work when I tapped on it. So let's give it a little touch up here. I may not have gotten this perfectly done over here either. I didn't strip these when I wired them on. I just melted the solder, melted it. All right, let's see now. Let's see, that's a 5532, so I want it to be right here, I think. 1, 2, 3, 4, skip one, and it, yes. All right, put my input back on. And my power. Okay. Well, that one's flashing now, but this one is not. Why? Oh. Wow. That's interesting. Yeah, I think this socket is about had it, I think. Let's try. There's the 71. And the quad. Turn that off. And put the quad in. Probably. And clamp her down. And turn it on. Everybody's flashing but this one over here. Why? Something's wrong. Okay. Well, do I have... It's a 102. R2 is a 102. R9 is a 1002. That's correct. All right. I'll be back in a minute. I'll figure out what's wrong with this thing. I'll let you know. Okay. Okay. I figured it out. Pin 8, which is another ground. If we look at the schematic here, pin 8, which is another ground, wasn't grounded. It just went to the flood in the back. So all the grounds except for the two on the two over here, all of the grounds weren't grounded. So I got to go back through and clean up this board a little bit. But I'll do that, and I'll get some more made just for the fun of it. But it is working now. Let's bring up the function generator and go to, I don't know, let's add a 0. They'll all be on solid, and they are. Add another 0. They're still all on solid, nice and bright, just like they're supposed to be. There's 1,000 hertz. There's 10,000 hertz, and everybody is still working. There's 100K. This thing quit, but the NE5532 is still working. Let's go for a meg. Nope. I shut it down. Even the 5532 won't go for a meg. Of course, that could be the design of this thing, but it does come on there, and everybody comes back on at 10K. So take it back down to 10 hertz so we can see what it's doing. And just for fun, let's take it down to 1. There we go. 1 hertz. And you can't see these very well because the camera is doing it, but it's working too. All right, well, there we go. It works. Finally. So a little bit of adding grounds to the schematic here, or to the board layout. We'll fix it, and everything will be fine. So there you go. Now I don't have to worry about wearing out, IC sockets and the likes. It'll work fine. So anyhow, hey, thanks for stopping by. If you like it, give it a thumbs up, please, and don't forget to subscribe. And if you want to support me directly, I have a page over on Patreon that you can take a look at and maybe drop a couple bucks my way. Whatever. Anyway, I really appreciate it. So, till next time.